In this lecture we will learn more about types and how the types are used when we declare a variable. And normally we think of a type as first being the type, such as int x, so that the type is to the left and then we see the variable name. But as we will see, when we have pointers, arrays and functions, the variable name or function name will be, or actually can be, in the middle of the type. So we will see how to resolve that, and we will start with what is called storage class specifiers. So we have already seen the static storage class specifier, and if we use static with the global variable or with a function, then that global variable or function are only visible within that file. If we use static for a variable or with a variable inside a block, then as always that variable is always visible within that block or nested blocks. But what is also important is that this variable will have a lifetime from the beginning of the program until the end of the program, and it will have a fixed memory location. Not like normal local variables, which are created when we come to the function and removed when we leave the function. I mean, they just disappear when we change the stack pointer, so that we cannot see them any longer. I mean, the memory is reused. The stack memory is reused. Okay, so what can we use this? What we should think about is that this variable will remember the value it had last time when we came to this function. I mean the value that it had when we left the function the previous time. Okay, so we can have the following scenario. We have a function and we realized we should do some initialization, but we don't want to change the application programming interface API to require that we call a special init function. Okay, so what we can do is to check if we have already called this function, and then set it to true, and I mean after we call it. Okay, so next time we will not call it again. Okay. And what else can we learn about with static variables? We can initialize them, and we can initialize them with the with a constant expression. So what does that mean? It is less precise than you might at first think. The 12 is clearly a constant expression, but this is also a constant expression, although we don't know the value of the constant. But if we think of this in terms of the memory layout, we can say that here we have instructions as usual, and here we have the stack. And since C is a global variable with the static storage duration, it will not be in the stack, but it will be among the global variables. So somewhere is C and somewhere is D. Okay, and okay, so the C gets the value 12 by the compiler when it creates a.out. And D is initialized to the address of C. That address will not change. The compiler knows the address, since it is the compiler which decides the address. So therefore it is fine to initialize it with the address of C. But E, it's also a static variable, and A, well, it is somewhere here. And what is the address of A? The address of A is the stack pointer plus an offset. Okay, and this offset is some bytes into the call frame of the function. The offset is known at compile time because it's the compiler that decides it, but the value of the stack pointer is unknown. So we cannot use this as an initialization.